Be doing the radians and degrees conversions video. This is what my what my table of contents looks like so far. These are pretty much everything is done on an ES puzzle. This is the first one we did before we left, and then it should be looking like this as you go through it. Okay, so now my next page, again, Pythagorean theorem. Obviously, it's not filled in because Miss Menard did these. Special right triangles, SOHCAHTOA, solving right triangles, part 1. Part 2, secant, cosecant, cotangent. And then today's video that I'm about to do right now, 9.7 radians and degrees conversion. Okay, and so the way you guys get to these videos, obviously in Edpuzzle, I'll have the 9.7 posted right there. Here's the calendar. This is last week, and this is this week. So this is the video I'm doing here for 9.7. I will have these worksheets up. Okay, so when we talk about radians and degrees, they are the same thing. Just like when you get weighed at the doctor's office, they weigh you in pounds. But in other countries, they weigh you in kilograms. And so degrees and radians are actually the same thing, just like pounds and kilograms both measure weight. These both measure angles. All right, so degrees are the ones you're most familiar with. And so, like, let's say I have a circle, and I start right here. Well, at that point, that's 0 degrees. And then let's say I turn to about this point here. Then most of you guys know that that's 90 degrees. And then I make a full half turn to here, and that's 180 degrees. And then make another quarter turn to here. That's 270 degrees. And these are all 90-degree increases. And then if I go all the way back to the beginning, well, then that also becomes 360 degrees. Okay, so that's degrees, right? Okay, so radians are very much the same thing, except they're measured with pi. If you guys remember, pi is that number that we don't write out. We just write pi, which is 3.14. But that's another way to measure degrees. And the way this works is that if I go a full half turn to 180, in radians, this is 1 pi. If I go 2 half turns all the way back to 360, well, that's 2 pi. Okay. Now, let's say I don't go the full half turn to pi, right? If I only go halfway, well, then that's half a pi, or pi over 2. Okay, so that means that basically every quarter turn is a half a pi. So from here to here, that's half pi. From here to here, that's 2 halves pi, which is just 1. And then from here to here, that's 3 halves pi. So this is 3 over 2 pi. Okay, so this is how radians works. It's basically the same as degrees, it's just a different way of measuring. And then what I'm going to show you guys is how to convert from radians to degrees and from degrees to radians. Okay? All right, so the first example I'm going to give you is, let's say we have example number 1. We have 7 pi over 6. So that's radians. So we're going to change this and convert it to degrees. All right, so we have this conversion. And if we're going to convert from radians to degrees, you're going to multiply the ratio that we know, which is that for every 180 degrees, that's 1 pi. Okay. So we want to cancel out the pi. So you notice how pi is in the top here in the numerator? Well, we want to cancel that out to get to degrees. So we're going to put pi in the bottom. So for every 180 degrees, we have 1 pi. Okay, so basically all I do is I take that conversion and multiply it. So multiply 180 over pi. What happens here? Well, the pi's cancel. Okay, and then I'm left with 7 times 180 over 6. Now I can simplify this out, multiply it out, however you want to do this. I'm going to kind of go back to like what we did with rationals and try to simplify. So I know that first I'm going to divide 180 into 6. Well, 180 divided by 6 is 30. So I end up with 7 times 30. And then 7 times 30 is 210. 210 degrees. So now I just converted from radians to degrees. Okay? Here's another example. Okay, so we're going to go from 2 pi over 9. We're going to do the same thing, and we're going to multiply the 180. So this is 2 pi over 9. So now 180 over pi. Again, just cancel the pi's. And now it's 2 times 180 over 9. And I'm going to simplify it like I did last time. So 180 divided by 9. Well, 18 divided by 9, that's 2, so this is 20. So this becomes 2 times 20, which is 40. So 40 degrees. Okay? All right, so that's how we go from basically radians to degrees. All you need to do is know this ratio, 180 over pi. Okay? And again, if you forget where does the pi go on top or the bottom, then just remember that when I have radians, the pi is on top, so I want my pi to be on the bottom when I multiply. All right, so now let's go the other way. Now we're going to convert degrees to radians. And it's pretty much the same thing, except now we just flip that same ratio. Now it's pi over 180. Okay, so for example, if I start with 120 degrees, okay, then I just multiply pi times 180. Or sorry, multiply pi over 180. Okay, now I'm going to combine this together. This becomes 120 over 180 pi. And now what I want to do is try to reduce that, because that's pretty much a fraction. All right. So I know that 10 will go into both of these because of the 0. But now I'm going to kind of like almost treat this like it's just 12 over 18 and say what goes into 12 and 18? 6. So I'm not just dividing 6, I'm dividing 60 because of the 0. Okay, so divide this by 60, that's 2. This by 60, that's 3, so it's 2/3 pi. Okay. Now the fourth example. Okay, so we have 180. Okay, so now again, same thing. Pi over 180. And as you guys can probably already see, this is pretty easy. And you probably, if you really think about it, you should know the answer before you even convert this. Oops, sorry. We don't want that there. It's repeating the same thing. Because we already know, like I explained in the beginning, that every 180 degrees is pi. So once I figure this out, 180 over 180, well, that's just 1. So this ends up just being pi. Okay. So if you have anything that's like an increment or a multiple of 180, like let's say 360. So if we, well, 360, well, that's 2 pi. Let's add another. Let's say this is an angle bigger than 360. So we add another 180, and we go back to here. Well, 180 plus 360, that's 540. Okay, that would be 3 pi. Then we add another 180. Now we're at 720. Well, that's 4 pi, and we just keep going, okay? All right, so anyways, that's just for multiples of 180. All right, now the last example here. Okay, 220 times pi over 180. Okay, combine those two, the denominator and numerator and denominator. Reduce that. I already know I can divide it by 10, but what can I divide into 22 and 18? They're both divisible by 2, so I'm going to divide 20. 20 divided by that will be 11. And then 20 divided by that would be 9. So it's 11 over 9 pi. Okay, and that's it.